2. 1, 2, 3, here we go. Hey, what's a logarithm? Did you ever wonder? Is it just like beating on a log? Gotta admit, I got some pretty good logarithm, if you know what I mean. Actually, a logarithm is simply the exponent you raise a base to get a power. You mean it's not beating on a log? I'm afraid not. It's the exponent you raise a base to get a power. A logarithm is the exponent you raise the base to get a power. Sing along with me now. It's the exponent you raise the base to get a power. All right, I'm going to stop singing now, and we're going to get to the notes because I am making a mess of my studio with all this tree bark from this dead log. This log's got no rhythm, and neither does this log. Let's get on to the note. All right, here we go. What is exactly a logarithm? Well, a logarithm, y here, is the logarithm of x to the base 10, or log of x to the base 10, or simply log base 10 of x, and it's written like this. Y is the power I raise 10 to get x. And you can see that we're going to take the y and x here, and that y becomes my exponent here. This is the exponential form, and this is known as our logarithmic form. And you see that 10 to the y power is going to return to me x. So simply put, logarithms are just exponents that you raise the base to get the power. Common logs have base 10, and they're often written without the subscript 10. So when you see log base 10 of x, it's equivalent to log x. All right, so let's get a little bit of practice just writing between the exponential form and the logarithmic form, just again so you can kind of see the pattern of how these go. So 10 to the 7th power is a 1 with 7 zeros, which means the log base 10 of 10 million here is equal to 7. So you can see the 7, my exponent here, is equal to the log base 10 of 10 million. It's the power I raise 10 to in order to get that 10 million. All right, 10 to the negative 3 is equal to 0.001. Now if I'm going to write that in log form, I'm going to write log base 10 of 0.001 is equal to negative 3. In other words, the exponent I raise 10 to in order to get 0.001 is negative 3. All right, now let's see if we can go back the other way from logarithmic form to exponential form. Here you'll notice that we don't have a base written in, but you remember that log without a base is really just base 10. So in other words, 10, my base, to 1/2 my power should be equivalent to the square root of 10. So 10 to the 1/2 power is equal to the square root of 10. So my root 10 here came over to this side of the equal sign. My 1/2, what my log is equal to, is the power, and then my base is 10. All right, the next one is just a generic version here. So I have 10 to the a power is equal to b. In other words, if I take log base 10 of b, it should give me back a. All right, let's do a few more examples here, and now we're going to actually evaluate these logarithms. So we see log base 10 of 10,000. In other words, what power do I raise 10 to in order to get 10,000? Well, this is a 1 with 4 zeros, so this must be equivalent to the number 4. In other words, 10 to the 4th should return 10,000. All right, log base 10 of 0.001. Now we saw this in our first example here. And so we move the decimal place over 1, 2, 3 places to the left. So this is what power of 10 do I take to get 0.001? And just like our previous example, that value was x is equal to negative 3. Or in other words, 10 to the negative 3 should give me 0.001. All right, log base 10 of the 5th root of 10 to the 3rd. Now, I'm actually going to rewrite this to say log base 10 of 10 to the 3/5 power. Remember, 3 is my numerator, 5 is my denominator. So, in other words, what power do I raise 10 to in order to get 10 to the 3/5 power? Well, if these are equivalent, then x must be equal to 3/5. So this logarithm here should be equal to 3/5. All right, same thing follows for our next one here, log base 10 of 10 squared. Well, I can rewrite that in one of two ways. I can write that as log base 10 of 100. In other words, what power do I raise 10 to in order to get 100? Well, that power should be 2. And then finally here, we're going to move our decimal place over 1, 2, 3, 4, 5 units to the left. So what power do I raise 10 to in order to get 0.00001? That should be the negative 5th power. So x should be equal to negative 5. Again, keep in mind that logarithms are simply the exponents that you raise the base 10 to in order to get a particular value. Okay, example 3, you're going to evaluate those on your calculator. Look for the log button and simply punch those in. For example 3, part A, you should end up with 0.423, and part B, you should end up with 0.699. All right, let's move into example 4, where we're using logarithms to help us solve and find the value of x. Here it says log base 10 of x is equal to 3/4. Now, we're actually going to rewrite this in exponential form, because what this means is it really means 10, my base, to the 3/4 power should be equal to x. So we can simply do this on our calculators. It says to take the 10, raise it to the 3rd power, and then take the 4th root of that, and we'll get the value of x. Well, when we do that on our calculators, we should get a value of 5.62. Next, we see log base 10 of x is equal to 1.5. So again, we're going to write this in exponential form. What this means is 1.5 is the power I raised 10 to in order to get the value of x. Again, on our calculators, 10 to the 1.5 should give us 31.62. All right, log base 10 of x is equal to negative 3.55. In other words, 10 to the negative 3.55 power is equal to my value for x. I'm going to use my calculator to evaluate this, and you can check it on your calculator as well, but you should end up with a value of 0.000282. And then finally here for example D, it says the log base 10 of x is equal to 0. In other words, 0 is the power I put 10 to in order to get x. Well, 10 to the 0, anything to the 0 is actually just 1, so x must be equal to 1.